Jon Magill, with 20 years of OT under his belt, more than a dozen articles on OT, 11 years of shipping MDF Rose engines, kits, and especially probably single-handedly tripling the number of people involved with OT with his machine. Please allow me to introduce our own author, demonstrator, innovator, and evangelist for OT. Let's give a rousing hallelujah for Jon Magill.
So, everybody hear me? I think like everybody in here, we all have a lot of different hobbies, and Brad doesn't know me that well, so I was really flattered when he asked me to talk about one of my other hobbies, which is I really like the way that ornamental turning overlaps with my hobby of knot tying and string and all the knot-related arts. So I'm here to talk about rosettes and mats. Now, the definitive book on this was presented at a Bridges conference in 2012. And the Bridges conference, for those of you that don't know about it, is an overlap of mathematics and art. And so it's an opportunity to bring things like these other technical hobbies sort of into the limelight. Now, diving right in, regular Lissajous curves, which is the simplest form of these, are just it's just a Cartesian equation that lets you simulate what would be done with a simple two-point pendulum. And so these are the kinds of curves that are generated, and these are the rectangular rope mats, the very simple ones that come out of that process. But the ones that I'm particularly interested in are the ones that sort of are closest to our heart, and those are the ones exemplified by these simple Cartesian equations at the top that is really the same math as what we use for like a geometric chuck. So, and the result, if you've got enough string, thank you, Brad, by the way. Brad Husby brought in some string, so we'll have a tying demonstration in the other room in a few minutes. But, I just want to dive into this. Everybody ready? Just kidding. I'm really here to talk about the other kind of rosettes. I wanted to see if everybody had coffee and, a little sense of humor this morning. I'm Jon. I'm an ornamental turner. Yeah, everybody? Thank you. Okay, I always do my questions up front, my surveys. How many people here that are attending live east of the Mississippi? That's pretty good for this one. How many people are left-handed? Also very good. How many people use a Mac? Oh, wow. It changes every year. I always ask those questions. And then the one I want to ask today, too, because at the end we're going to get into this. How many people use computer-aided drawing or drafting, CAD, or things like that, are familiar with CAD systems and drawing systems? And have been doing it for more than 5 years? Wow, good. Okay. So, I worried about this talk, and I'm going to cover a lot of stuff because rosettes are interesting, but I thought it was hard to make this topic interesting to a lot of people. And so I'm going to cover a lot of stuff, and it's going to touch on different things. If you fall asleep for part, maybe you'll wake up for the other interesting part. I'm only here because I stood on the shoulders of giants. And I'll break down again, and I do every time. I went to Bonnie's, and I met Gorst. That's a story I'll tell on the next slide. That got me hooked. And then I bought my first lathe, Paul Clare lathe, and that's a Pudsey Dawson lathe. So I cut my teeth on a moving toolbox instead of a rocking headstock. And then I met Paul Fletcher through the OTI, and we collaborated on what became the MDF. And of course, Fred Armbruster's been a friend since day one when I met him. And so my key question is, would you buy a lathe from this guy? He's not here, so I can make fun of him. I've been doing this for about 20 years. I was at Bonnie's house. I ran into Gorst, and what I call Sleepless in Seattle. There was a vase of flowers on her mantle. I asked how it was done. I knew it came off a lathe. Gorst was visiting from out of town, from Louisiana, and he showed me my first view of a rose engine cutting a piece, and I was addicted, and I didn't sleep for 3 nights. Then I went to the first OTI. This is my 10th OTI meeting. I went to my first one in Kennebunkport in 2000. And that's when I met Fred and got to see his shop and got to see the Mark I in his basement at the time. And then the next year, right after 9/11, I was in Illinois picking up my Claire lathe. And then 2004, Paul Fletcher and I hosted the OTI meeting in Silverdale, Washington, and Paul came over for that, and we sort of cemented the details of what would then be slightly interrupted by prostate cancer, the publishing of the MDF lathe in the AAW journal and the plans for everybody to do that. And then I finally, a couple years later, got my Mark II. I'm going to dive in not to my personal history, but the history of rosettes relative to ornamental turning. There's a lot of books. Not many of them talk about rose engine turning, and I've made that point in most of my talks through time, because when I first saw ornamental turning, I'm interested in ornamental turning, but I'm specifically interested in rose engine turning. To me, the instant gratification and the geometric patterns that are endless, that's the part that fascinates me. But it fascinates me that we've known about it for so long. So Bergeron is probably the book that most people refer to, and I don't know how many people in here have actually read it. I'll talk about that in a second. But in Bergeron, around 1800, he said we've known about rose engines for 150 years. But in a footnote that Jeremy Soulsby added to the Bergeron translation recently, or 2010 was when that was finished by the SOT, he says that now we have evidence that it's 200 years earlier than that. And so I think that's pretty phenomenal. So I put together a timeline just to help. This is sort of US-centric on the left side. Columbus sails to the New World. Guess what? We already knew about rose engines. The Plymouth colonies established. Guess what? Bergeron thinks that's about the time rose engines came into existence. I snuck Newton in here because he's a personal hero, but about the time of Newton, Plumier in 1701 publishes his first edition of his book. And then we're going to dive into this in a lot more detail, but there's this guy, de la Condamine, and if you haven't heard of him, you're going to learn about him today. And he presented 2 papers to the Academy of Sciences in Paris in 1733-34, and these were so important and that they were included in de la Condamine, or in Plumier's second edition a few years later. Then we jump forward to the Declaration of Independence, and Diderot, who some people, I don't think it's as famous a book, but it has a lot of details in it. But that's quickly followed by the first edition of Bergeron, just almost around the turn of the century. And this is the book actually written by Bergeron himself. I'll talk about that in a second. And then about 18 years later, I guess, his son-in-law updates that and writes the second version, second edition of Bergeron, about the same time that Spain decides to give the US Florida. And then we have this little altercation over here called the Civil War, and that's about the time frame that HOLTZAPFFEL is active, doing everything he's doing. It's the beginning of the Victorian era. And then I ended my timeline at the point where I think interest in ornamental turning suffered the greatest hit, which was the introduction of the automobile and the change in activities of the leisure class, of the landed gentry and nobility, particularly in England, where ornamental turning was very popular. And that's coincidentally about the time that Evans published his book on ornamental turning. So, talking about the books that I think are important back in that time frame, Plumier, if you read Plumier, and Paul Ferraglio, who we'll talk about later also, did a great translation of this in 1975. But Plumier, we've all seen the plates, but probably most of us haven't read it. I've read it. And the thing that I take away from it is Plumier talks about making a rose engine, where Bergeron, 50 years or 100 years later-ish, talks about using a rose engine. And that's a very different distinction between those 2 books and the kinds of topics they cover. And then, as I said a minute ago, in my opinion, with the end of the Victorian era and the introduction of the automobile, and about the time Evans wrote his book, there's just a huge gulf of knowledge that just dries up, and ornamental turning pretty much falls off the face of the earth for another almost 50 years. Norman Tweddle wrote a book that if you're a member of the SOT, it's on the SOT Bulletin CD. It's a great book on how to use a rose engine. It was written in 1950, and it's electronically available on the SOT CDs. Martin Matthews, there's a reprint. The SOT has just reprinted his book, which the original edition of that book, I think, was only 150 copies or something. It was unobtainable. And all the people in here that are interested in guilloche, that's probably the most readable book on engine turning. Yeah. Wes has a copy. He'd be glad to pass around the room so you can all enjoy it. That's the reprint. The old ones, the original ones, are a little more fragile. And then I always refer people to, especially people that are starting in ornamental turning, I always talk about T.D. Walshaw's book, Ornamental Turning, because I think that's, it's the most readable contemporary English, but it doesn't touch on rose engines. There's a little blurb in the back and one reference in the appendix, but it doesn't talk about rose engine turning. So now that we've covered what you can read or not about rose engines, let's talk about the history of rosettes. So like I said before, Plumier, in his day, if you wanted a rose engine, you probably either had to build it yourself or have somebody build it for you. It wasn't like you could go and waltz down to HOLTZAPFFEL and plunk down your money and say, I'd like to order this lathe. So Plumier came out with each of these guys, Plumier and Bergeron. It's always confusing because they each did 2 editions of their book, and they were the definitive works of the time. But Plumier's first edition, 1701, and he actually wrote the second one about 50 years later. And he describes in gory detail laying out the rosettes, the styles of rosettes that were popular at the time. But the thing to notice here and in the pictures after this is all these rosettes have a square hole. So that means there's a piece of the rose engine missing in Plumier's time that we're all very intimately familiar with. So here's some example of Plumier's rosettes and stuff sort of his contemporary time period. And I make a note in the title here that the French prefer 16s. And so if the world had sort of come down differently, you know, we're sort of post-colonial residents of English-inspired colonies and history. So we've adopted the love of 12s, as David pointed out. I think that's his favorite number. But the French preferred 16s for the longest time. And if you see the old rose engines, you know, you could pretty much tell if it has rosettes that are multiples of 12s or have 12s as divisors, it came from the British lineage, and if it has 16s, it came from the French lineage. Note the square holes. So here's a barrel of Plumier-era rosettes. And these are, by modern standards, and even Bergeron standards, these are pretty rudimentary. Backing up a little bit, there's the lathe, and it still has some sort of common features that we see in more modern lathes. The screw box at the back with these levers allow you to lift up and engage the screw hobs to do threading and things like that. But the rosettes themselves are all mounted on this square mandrel so that they're all timed ahead of time by the way they're manufactured, and there is no phasing at this point in time. So along comes Bergeron, and things have changed a lot by his time frame. So he's going to write his own first book in the end of the 18th century, 1792. And then his son-in-law is going to take up the torch, and he's going to publish the second edition. So when people talk about Bergeron, they're talking about the book, not the person, because it's 2 different people. And it depends on which one you read. In 2010, the SOT underwrote Jeremy Soulsby's effort to translate Bergeron. And although I've read earlier versions of Bergeron, Jeremy's translation is very readable. If you have any interest in this, I really encourage you to at least read the chapters that are interesting to you. It's a very approachable book, and it's an excellent translation, and it's filled with tons of great footnotes, including the one I mentioned earlier, predating the rose engines back another 200 years. And anyways, when we get into Bergeron, his whole thing is we're going to see that rose engines change dramatically. There's a few things that changed. I don't know the reason for this. I'm not a pure historian. I'm a sort of a technical historian. I look at things and read about stuff that interests me, but I'm not focused on the pure history. But one thing I cannot figure out or have not come across yet is between Plumier's time frame and Bergeron's time frame, rosette diameters went from a very usable 6.5 to 8.5 inches in diameter down to these later French ones that are more ornate incorporate pumping or crowning, and they're down in the sort of 5-inch range. And I don't know why they shrunk in size. I haven't been able to find anything that talks about that. When you're making rosettes, that's a huge difference. And I don't know if they didn't understand it or the lathes had changed or what, but on both of these sort of Bergeron era rosette or rose engines, the rosettes are significantly smaller. The machines are basically the same, but the rosettes got smaller, which means, you know, for a given amplitude, you now have tougher, you know, ditches and valleys to get in and out of, and it makes everything about using the machine more difficult than the larger rosettes, which we'll come back to in our modern era. HOLTZAPFFEL and others, you know, and Plant went to much, much larger rosette diameters, which makes them more usable on a machine. The other thing to notice is we now have a click plate and typically a worm by the time we get into these Bergeron era machines. So that's the big change from Plumier to Bergeron, and that happened in about 100 years. But the thing that a lot of people don't know, and I mentioned that I cut my teeth on a sliding toolbox machine. The Claire lathe is a Pudsey Dawson design. The headstock, it just is rigid and turns, and the toolbox moves under the influence of a rosette. My particular machine, the rosette, is decoupled from the spindle, so you can have a gear ratio to multiply a rosette up or down. So at 8-lobe rosette, you can increase it or decrease it by changing the gear ratio between the drive on the rosette and the drive on the spindle. That's not common on a lot of lathes, but the sliding toolbox was known about from Bergeron's time. And Bergeron, actually, if you read the book, divides the world of rose engine turning into 2 distinct camps. The rocking headstock camp, of which this is an example, and the sliding toolbox camp, of which this is the example. This was used commonly, much like my Claire lathe, many, you know, a couple centuries, or a couple millennia, many centuries later. Moving the toolbox means you can just mount a rosette on the spindle itself and move the toolbox. You don't have to have a rocking headstock with a barrel of rosettes. You can put the individual rosette you want and modify almost any existing machine. And so that's why Bergeron goes to the trouble of delineating and explaining the 2 completely different camps of how you approach rose engine turning on 2 different styles of lathe, the rocking headstock and the sliding toolbox. And this is just one flavor. There's about 30 flavors of this type of machine where the toolbox itself moves. And he illustrates a couple in the book, but I'm just putting this up to tell you, you know, what Gorst always says, you know, everything that is old is new again. This has been around forever. Bergeron delineates and separates the 2 discussions to talk about the anomalies between them. And it's just important that we all know, you know, they knew about this a long time ago. I was going to read this in detail, but you can sort of read it while I talk. Bergeron made the point that making accurate rosettes is difficult, and they have to be accurate or they look like crap. And so I have had, since I started doing the MDF rose engine, I cannot tell you the number of people that have come up and said, well, I tried to make my rosettes and blah, 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 blah. And, you know, it's like the dog, you know, blah, 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 food, blah, 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 blah. I've heard it all before. It is incredibly hard to make good rosettes. And so then the rosettes have to be dead on accurate, especially, as he says in the last part of this, if we're going to introduce phasing. And so by Bergeron's time frame, we had click plates, we had phasing, and they know what's going to happen when you rotate a rosette and cut another cut adjacent to a cut you just made. And if that rosette isn't perfectly concentric, if the peaks and valleys aren't perfectly matched, it's going to look terrible, which is what he says here. In the latter case, the defect produced by a faulty wave continually being opposite the line traced by a regular one results in a very disagreeable appearance. That which we state here will become even more apparent later when we come to give the details of the art of rose engine turning. So, you know, this is the language, courtesy of Jeremy, it's translated, but, you know, it makes the point that a crappy rosette is going to make your work look crappy. With that, let's dive into the geometry of rosettes. Is this interesting to everybody? Do I need to steer it any? Okay. If I see eyes glazing over, I'm going to kind of change the topic a little. De la Condamine, Monsieur de la Condamine, in 1733-34, did these 2 papers. And the papers, I think, are probably for me, as a guy who was interested in making rosettes, there ain't much, you think there's not much written about using a rose engine, there sure as hell isn't much written about making rosettes to use on a rose engine. And De La Condamine is the person who wrote the definitive work, and it wasn't easy to read, and it got some challenges. But he did what he needed to do, and he got it out there. And he focused, although he focused on a number of problems, the two important problems that he focused on are, given a rosette, tell me all the patterns that are possible with that rosette, and then for a given shape, tell me the rosette that will produce that shape. Now, if you're a guy that makes rosettes, I've made a couple thousand rosettes, I need to know about that, and I need to understand how to make that into something you can just use as an end user on the machine. But the bottom line is these two parts of the problem are very interesting. And they're interesting enough that, like I said, Plumier's second edition includes in an appendix almost all of De La Condamine's content of his papers. He had some other points in there, but these are the two that matter. The drawings here, which I'll talk about in a second, but these were the important drawings out of his original paper showing a square up at the top and the two obvious patterns we're all familiar with that you could get from that if the square was the rosette. And then the middle one is the angular problem, which we won't talk about in length, but if the cutter and the rubber are not collinear, you get certain types of distortion, and how you describe those distortions with the fixed angle between the two, blah, blah, blah. That's what the second drawing is. And then the third drawing we'll see again a couple times, because that's the seminal drawing of the portrait that De La Condamine used as the example of, I know the thing I want to do. I want to make a cameo, and what's the rosette shape that I need to make that cameo? So the most important piece of apparatus for me that I ever learned about in ornamental turning is De La Condamine's compass, as he called it. And it's not useful to most people in this room, but it's useful to understand what he did with it and how he described it. I'm not going to use his as the example because I've got another one that's easier to understand. But this was the drawing in De La Condamine's paper where he had this compass that would allow him to trace the portrait, the silhouette down below, and produce the corresponding rosette pattern with this mechanism. So fortunately for me and the other people that wanted to go down this path, Paul Ferraglio translated Plumier in 1975 into readable English. And he wrote extensively about De La Condamine's papers in there. And then Paul Ferraglio, who recognized the importance of these, went on to do more with it to call it out. But he writes, these two papers are by far the most penetrating study of the relationship between the rosettes and the patterns it can produce that I have yet met. And that's a gross understatement, because what De La Condamine outlined back in 1733-34 is still the definitive work, in my opinion, of how rosettes are, how you come to understand rosettes and the possible patterns they produce. Ferraglio recognized this too, and there's he wrote an article that that is in an SOT bulletin, number 52. Let me take this off, and I don't want to commit the crime that every other speaker has, walking away from the podium with the microphone attached. Let me pass that around. So this is a layperson's condensed version of what De La Condamine produced, and then Ferraglio went on to turn into an SOT bulletin in two parts called The Geometric Problems of the Rose Engine Lathe. And I'm just passing around, not that you need to read it, but that you need to know that it existed, because that's what turned me on to the whole path I went down to understand rosettes and sort of do something about it. And then Ferraglio, more importantly, also cleaned up and modernized De La Condamine's compass. So Ferraglio redrew, you'll see coming around in this paper, he redrew the drawings that De La Condamine presented, and then he went on to discuss them, in sort of plain English. If you have a vector from here to here, and the rubber's here, and the cutter's there, and blah, 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 this is what's going to happen. And he outlined exactly the two cases you just saw in De La Condamine's original papers. But he went on to also draw and design a more modern version of De La Condamine's compass. And so in this case, the upper right corner is the top view of his compass, and you can kind of see the portrait in sort of shaded gray there, and you see the letter O there, which is where his tracer would be that's going to go around this portrait, and then the letter T is where the pencil or whatever, the drawing item would be that would draw the outline of the rosette you're going to need for this arbitrary shape, a silhouette in this case. And he just used this as the extreme example of something that none of us could normally visualize being turned into a rosette. I'll come back to that at the end of the talk with kind of a more realistic, down-to-earth version. Dang it, I forgot a prop. At the bottom, you sort of see the side view, and you can see where O is down below, that it would be tracing around the object, the portrait, and where T is, that would be where your pencil was or whatever that would draw this. And I've seen different versions of this built. Fred made one where he actually, the post at C is held in a drill press so that it can actually be suspended over the top of something, because this whole thing has to rotate around the sort of center of the object. Point C in this drawing, it's sort of the center of mass of the object that you're trying to turn into a rosette, if you will. You can't have that be way off by the top of the head or down by the neck and get a rosette that has any semblance of balance. So you're kind of looking for I call it the center of gravity, center of mass, where the center of the bulk of the object is that you're trying to turn into a rosette. And so he's got that position kind of in the middle of the head, and then you're able to rotate it around. And these sliders, where you see the letters B in the lower drawing, that's like a little V-rail on sliders, idler pulleys that let it roll back and forth, so that as you press O, the tracer, against the edge of this pattern you're trying to turn into a rosette, then this slider will slide over and T will let you draw at the other end. Can everybody kind of visualize that? Does it make sense? It's one of those things where I read the paper, but until I physically saw something in person that did this, it didn't make as much sense, but maybe I'm slower than the rest of you. Ferraglio also, I'm not going to go into it, but he has a discussion about, and as does De La Condamine, about the tracer, the shape of the tracer, which I put in on the upper left here. So imagine, making something that's going to be the shape of your cutter head, a round cutter head that's a facsimile of the diameter of your fly cutter, and or a pointy tracer that's the shape or approximate size of your rubber. Those two things will contribute to changing the geometry of the resulting rosette. Here's just the example. Now, I'm gonna diverge from this, or as I like to say, politely disagree. They had reasons for the things that they focused on, and almost all of theirs were opposite side rubbing. So in the previous drawings and here, the tracer is down at O, and the drawn edge of the rosette is up at T. I'm actually going to invert that when we get into modern techniques to make rosettes, and I'm going to actually put O up at the top of the head and draw at T, if you can envision it, from this drawing. What he's drawn here, and both De La Condamine and Ferraglio described, is rubbing on the opposite side of the rosette and essentially inverting it to create this rosette. I'm going to do a near side rubbing and cutting version in my approach, but you can do either one. I'm just not going to talk about it at length. So all that...
John, would that mean that you would have to, when you use the rosette, you would have to cut on the right side of center?
Exactly. So, that's, and most, I oversimplify it to be, near side rubbing, near side cutting, because that's how I designed the MDF, to keep it as simple as possible, one tower. But for people that have two towers, you can either rub on the back and cut on the front, or, as you know, just move the cutter to the other side. And they did this for geometric reasons, because it dumbs down the curves. And this is part of my confusion about why they went from bigger rosettes to smaller rosettes in Plumier's era. I don't understand that. And he was a contemporary of De La Condamine. So it doesn't make sense, because De La Condamine makes the point. Oh, thank you. There's another prop I need. Could you go get that out of my drawers? De La Condamine goes on about, essentially the effect of softening with this longer distance that you have. If you're rubbing on one side and cutting on the other, it softens the rosette. But we've gone back to bigger rosettes, so we get back the benefit. We don't have to do the longer vector in this case to get the effect. So none of us, almost none of us, have seen De La Condamine style cameo cutting rosettes. We've all seen Holtzapffel's rosettes. And Holtzapfel didn't do any of this. So, and I also always like to point out, Holtzapfel only made 16 rose engines. There's some conversions out there and all that. Plant by far eclipsed what Holtzapfel did, but the rosettes are different because they were designed for primarily guilloche metal work as opposed to woodwork, which Holtzapfel's machines were predominantly focused on. But it's worth talking about Holtzapfel's rosette forming machine. I've seen it, but you can read about it if you have access to a copy of Jon Edwards' Volume 6. Jon Edwards, gosh, how many years ago now? Anyway, probably back in 2008, 6, something like that. Jon Edwards took on the Herculean effort of compiling and amassing all the documents that didn't really get published, that probably woulda, shoulda, coulda become Holtzapfel's Volume 6 if he actually did it. And so it's really the place where it's not a how to do rose engine turning, but it certainly has all the collected information that would have been available to people who were trying to do rose engine turning. And in particular, he's got a chapter. I'm going to go ahead and pass both of these around too, without committing hara-kiri. He's got a chapter on the rosette forming machine. I'm going to pass that around in a little booklet form, and then you'll recognize almost all the shapes we're familiar with when you go through the rose cutting frame. I'm not going to talk about that, but you can flip through this and see sort of the rosette patterns that Holtzapfel described and knew about, and these are just for your viewing pleasure. The prop that I keep mentioning that I didn't bring is over in the other room, and if you want to see it after the talk, you can come over and hit me up at my lathe. Yeah, I don't know if the drawers are unlocked. Yeah, Bonnie, my backpack is right behind my cues, and in the front pocket there's a, come this way, come this way. Mike Hughes, raise your hand, right behind him. The front zipper pocket there, right up top, higher up, higher up, higher up. There you go. There's 2 keys in there, 2 round keys. I think third drawer down, there's a Shamrock cut sample piece in my sample boxes, and then in the bottom drawer, find the Shamrock rosette if you can. That's your personal challenge. The rosette forming machine is a very interesting piece of equipment. The piece that Jon has in this little booklet that's passing around is the written transcription of some really hard to read, hand-scribed copper plate that I've seen copies of, but I'm thankful that Jon took the time to translate it, and so you can see it here or read it in his book. It was, Jon thinks it was from the notes of George William Budd, who later changed his name to Holtzapfel Budd. And they think that this machine was made out of essentially spare parts laying around the Holtzapfel shops around 1840, which is about the time they produced the first real rose engines. This is a little bit bigger picture of the one that's in that pamphlet, but you got to see this thing in person, and this is the first time I saw it at the Science Museum Reserves collection. It is you got to look at this thing from all sides because it is not an obvious piece of equipment. I understand rosettes, I understand machining, I understand math. This machine is just mind-boggling in some senses. And of course, it's in a museum setting, so it bears no resemblance to how it was actually being used. And so you kind of have to make up the story a little bit, except that thankfully, the SOT guys and the people at the Science Museum, this is probably before Michael Wright was there, but the people knew what they got. And so here's a picture of it when it was actually stringed up and running, or ready to run. And the belt and strings, the gut used to run this thing is incredible because there's so many moving parts that to sort of understand how the whole thing works, it really helps if you could see it all sort of strung, ready to work. The string that's going across the top is going up to run this gear train. See the complicated gear train up at the top? We'll talk about that in a second. And then down below, you see this thing that looks like a record player platen, if you're old enough to remember those. And you'll see that there's a piece of gut going around that as well, because it's got to turn that drum. It's got to turn this thing that's on my handy. This is the shaft that has a cutter on it. We'll see it in a better picture. And this is the rosette being cut. And this shaft is on a slide, which is sliding in and out this way as a result of this reciprocator, like we all saw Al's version of the reciprocator. Here's Holtz's version of the reciprocator. Every time this goes around, it's sliding this slide back and forth, which is taking this cutter and sliding it back and forth across the edge of that rosette. I'll talk about more features of this in other pictures, but that's the machine, okay? This is the back side of the machine, which is the part everybody cares about, but this is a bad picture, so I have a better picture. But there's the arbor that has the cutter on it, okay? Here's the slide that it's sliding back and forth on so that it can make slices across the thickness of the rosette, okay? Got all that? Here's the gear train, and the gear train's going to come into play in a minute. But more importantly, down here, see these two shafts going up to the gear train? At the bottom of these shafts are two cams. And the cams look like, well, these are example cams. These aren't the cams. But there's two cams here. And so these are the shafts coupled by this enormous gear train that's going to decide how many multiples of each thing are going to occur in each revolution of the headstock that has the rosette that's being cut on it. And so down here you can kind of see this cam has kind of a little blip in it. You know, it could be an F-type cam. It's not, but it could be. And we'll talk about that in a second. And then, you know, this is just a cam that can be offset eccentrically. If you look at the machine and back at the pictures of the machine, you know, sitting as I saw it in the museum or even as they had it back in the 50s, there were a handful of these sort of simple-looking one-feature cams sitting there on the table. And these cams that have, if you remember Ken's discussion yesterday, here's kind of a flat edge. Remember what that flat edge did to Ken's piece of work when it was traced? Here is the classic F. We talk about the F being the heart rosette, but you see an F4 or an F8, it doesn't make sense, but it's this heart unfolded and wrapped around the periphery of a rosette. But the secret to all of this is what is the difference between what I call the simple rosettes and the complex rosettes. This is underneath. Here's one cam. That's the eccentrically adjustable cam, which is going to allow us to have different amplitude coming through in a predominantly circular or sine wave type rosette. And this is the feature cam. And between the two is the compensating lever or summing bar. It's the thing that takes variable contribution from the two cams, and then because of the location of this adjustable fulcrum, which can slide in this slot, you can decide how much of the circular cam and how much of the feature cam do you want in the given periphery of a rosette. The machine is amazing, but it's very simple once you distill it down to the parts. I know you may not think that, but I mean, as an engineer, I look at it and I say, they were brilliant. I understand how it works. Now I can translate that to the modern day stuff that we need to do. So the example of the simple rosettes, these are just the sine wave, the A rosettes. And then this is a simple, I call it simple because there's nothing really magic going on with the rest of the gear train too much. But these are like the F family. It's just the heart shape wrapped around 3 times or 4 times around the rosette, unwrapped around it. You're the one. Perfect timing, thank you. The more complex or compound rosettes are the ones where you have these combined features. Thank you very much. You have these combined features where you've got, you know, you might recognize this as that sort of looks like a 4-sided polygon, but I see a bunch of ripples on it. And so that gear train that we saw on top of the forming machine, that gear train is determining how many times the one that's contributing these bumps is rotating versus how many times the major component is rotating. And in that same vein, the one we're probably mostly familiar with is the J family of rosettes. I think Steve showed one in his I forget, you call it fish lips or something like that, but this is the J36, I call it a J36.6, or this is actually Holtzapffel's version of J36.5. It's got 5 bumps on 6 larger bumps going around the outside. And so these multiples are all created by rotating the 2 cams at different speeds, different times, different numbers of revolutions. And that's how all of his rosettes were made. That's the entire collection of Holtzapfel rosettes was made in one of these 2 techniques on that machine that's going around in the pamphlet. And so I told you we'd come back to this one for a little closer view. So here's the cutter, and it's on a slide here, sliding back and forth. This is just a reciprocator arm. You can change the eccentricity to, if you're cutting a thicker or thinner rosette, you can have it move farther, more or less amplitude, so to speak, in the slide. And this is just gashing the edge of the rosette with what we'd call a slot cutter today. That's adjustable. But then the other little feature here, everybody see this? So this thing is just a Holtzapfel headstock. Remember, this is made from spare parts laying around the shop. Well, if you take this headstock and rotate it 90 degrees, what's going to happen? Anybody know what you get to cut? Exactly. You get what I call a crown or a face rosette. You would be cutting that feature in the face of this with that gashing cutter on a radial line, and you would get exactly the same features in one rosette. And so when Holtz made for the true rose engines, the rosettes that have that pattern on the side and the pattern on the crown or face, this is the machine that did it with just one simple swing of the headstock. Okay, that's all fine and dandy. I don't work with antiques. Yeah?
I look at that picture, and one of the things that puzzles me is that slitting saw, as you call it, what kind of crew produced a finished rosette? Was there a lot of handwork done after the initial cut, do you think?
Nobody is still alive that worked in the factory. So many people have posed that question. Nobody's stepped up to answer it exactly, but they had a lot of abrasives. They had this thing, you can change the ratios of that so that, and you can use as thin a saw. Nobody knows if that was the slitting saw that was used for the predominant rosettes. But for an A rosette, no problem. That would do it. For an F rosette or some of the ones with very, tight little valleys, probably that one wasn't the one they used. And so nobody knows. We can only speculate. You can look at the edges of the Holtz rosettes. There is no sign of a gashing cutter. So I don't know how big the army of filers and sanders were that they employed, but there were people doing some finish work on the edge of the rosettes to polish them up. But this got them to the correct geometry. Yep. Any other questions before we shift gears? Everybody still with me? We only got a...
John, my recollection when I saw that machine was it was treadle power.
Yeah. Fred and I were talking the other day, and with the David Wing rose engine has changed hands recently, and with it went some papers, and one of the papers was the Holtzapfel and Dyerlin inventory of the premises in 1800, and they went through room by room in the entire factory to inventory everything that was in there. And the predominant thing that stands out on that inventory when you look at it is the number of candlesticks per room. So, yeah, it was treadle powered and it was lit by candles. We kind of forget about our modern conveniences, forget about the internet. I mean, just having light is a convenience. Okay, so I'm shifting gears, and the reason I asked about familiarity with CAD is we have this amazing tool, CAD, CAM, and CNC at our disposal now to do things that Holtzapfel couldn't have dreamed of, or much less Plumier and Bergeron. But we're standing on their shoulders because they told us all about the geometry that we needed to do this stuff. So my best example for making rosettes is a friend of mine quite a few years ago raised Irish water spaniels, and he wanted a Shamrock rosette, and he said, "Can you do that?" And I said, "I can make any rosette." And so I proceeded to, and to me it was sort of an offhanded, flippant remark that sure I can make a rosette, but it didn't occur to me at the time because I didn't think of it as a challenge because I had read De La Condamine stuff and I knew how rosettes are designed and made. And so you give me a shape, give me a challenge, I'll turn it into a rosette. For God's sake, he produced a cameo. I can certainly produce a shamrock. It's not rocket science. And so what I thought I would do is use that as the example, but I'm going to simplify it for the purposes of the talk. But I'm going to walk you through the process to make the shamrock, and we'll come back to it after a simpler version. All you need is a pattern. So my friend said he wanted a shamrock. No problem. What does a shamrock look like? So I go out to the internet, and you can find your source material any different way you want, whether it's a JPEG of a picture of a bunch of them growing, some stylized, iconic representation, or somebody's logo. It doesn't matter. Pick something, and then turn it into the drawing that you're going to make. Now, I know a lot about rosettes, so you'll notice that the thin, skinny stem of this thing, I know that's not reproducible on a rose engine. And so I said, well, this is a good representation. People that see that will know that's a shamrock. Even if it doesn't have a 6-inch long hair-like stem on it, they'll still recognize it as a shamrock. And so I put a little bit of intelligence into how I'm going to modify that stem so that the rubber can get in and out of what I know the 7-inch plus rosette is going to look like that produces the 2-inch diameter shamrock, okay? So start with an image, figure out what you want to make, and then scale that to whatever size you want it to be. Now, I get a lot of people asking me, I want to do 12-inch bowls and I want this design on the edge. A rosette for a 12-inch bowl that isn't washed out is very different than a rosette for a 2-inch shamrock. And so you got to know both the target size of the workpiece that you want to produce and the shape or whatever source material that you want to put on that. And people don't understand typically that the amplitude of a rosette is fixed. It's built into the rosette. You can have a machine with an amplitude adjuster, but for the most part, you're going to have whatever amplitude is in the rosette is what you're going to get on your workpiece. And that's why we get the real spiky stars when you get down to small diameter, and it gets washed out when it's out at bowl diameter. And so, but you can overcome that by designing rosettes to do a specific task. This one, the friend wanted to put 2-inch medallions around the edge of a 16-inch platter. So I knew he wanted 2 inches. I designed this to be 2 inches. And typically, I'm aiming for the type of work I'm doing for the 2 to 3 inch diameter effective results from my rosettes. But whatever you're doing, if you need to make a rosette, just keep that in mind. You can make it work on 12 inches or 24 inches or 1 inch. If you're doing jewelry scale stuff, dumb down the amplitude. Make a rosette that makes sense for that scale of work. Then you have to know about the machine that the rosette is going to go on. In my case, because of the way the pulley works with the externally mounted, the outboard mounted rosettes, I have a pulley that I need to get outside of that. So all of my features on the rosettes for the MDF rose engine have to be 7 inches and out. So I have a root diameter of 7 inches that I go out from. Fred made the Mark II. He made a bunch of blanks out of brass, or 732, whatever. He made them out of brass, and they were 7 inches, and he could only cut smaller in from that. So the blank material was 7 inches maximum, and he cut smaller than that. So you have to know the root diameter of whatever machine you're making your rosettes for. And then I said I'm not going to get into it, but you need to know, is this a near side or a far side design? So what De La Condamine drew and what I draw are the inverse, because I'm designing it predominantly for machines that have a front side tower and a front side cutter, operator side cutter. And so but you can do either one. There's no magic here. You've all seen a rosette invert. We're just inverting it. We're going to invert it in the drawing process ahead of time instead of inverting it in the cutting process at the end. And so now let's just dive in using CAD and my version of De La Condamine's compass. So I'm going to start that with a simple polygon. I'm going to draw the desired shape to scale. I'm going to draw the root circle, because that's the thing I care about. In my case, I got to get outside of the root circle. I got to cut bigger than that root circle. And so I'm going to then lay out a bunch of radial construction lines that make sense for the thing that I'm drawing. In this case, you'll see in the next slide the polygon. But I know there are features on the rosette that I have to take into account when I design the rosette. And so you can't just arbitrarily have these radial lines going every which way. You want them to come out in line with specific features of the thing you're trying to produce. And then it's a very simple operation, just like De La Condamine's compass, if you understand that. is to find the shortest or longest line, depending on your rosette. In my case, I find the shortest line and use that as the minimum length. And then I replicate that line all the way around the features of the pattern I'm trying to produce. And where I can, I take advantage of symmetry and polar duplication to make that an easier task. So here's our simple rosette for today. I draw, in this case, a hexagon, and then I draw my root circle. So in my case, all of the parts that are on the body, the edge of my rosette, are going to have to be outside of this circle someplace. If I was making a Fred-based rosette, an armbruster rosette, I would have to come in from that circle, and all of my lines would be somewhere in here. So that's the only difference you're going to see. And again, this is a near side cutter, near side rubber. So the first thing you have to do is add radial lines. These are just construction lines. They're helpers for me to draw my thing, but you got to be smart about it. It's an art, not a science per se. And so, yeah, this takes into account the midpoint of that and the corners, the apex of each part of the polygon, but that's way too few. You're not going to get a representative set. You're not going to get an accurate line to reproduce this goofy looking shape that's going to ultimately be the rosette that cuts this hexagon. So then this is a few more, but they don't go through the corner of the polygon. They're not through the middle of the side. So they're missing all the key points of the actual underlying sort of geometry of the thing you're trying to produce. And then I just sort of say in baby bear, mama bear, papa bear, this is just about right. I've got enough radial lines that they're going out. They hit on the midpoint of the center of one of these lines. They go through the apex of the polygon. So that's about enough radial lines for this particular shape to make a reasonable rosette. Does that make sense? So now that I've got those, I'm going to, in my case, for my rosettes, I'm going to now draw some lines on some of these, and I'm going to find out what the distance is from one of the apexes on this polygon out to the edge of my root circle. Now, that's 2 inches. But if you look and I draw a line from the midpoint of this side of the polygon out to the circle, it's 2.2 inches. I now know that's the longer of these two lines, and I know that that's the shallowest point on this whole shape I'm trying to reproduce, and if I know the distance out to my root edge, I know that a 2.201 long line is going to make it right to the edge of that root, okay? Does that make sense? So now, if I use that length, but I put it on every point of this all the way around, that extension will give me where I want the periphery of my rosette to be. So now I've taken that 2.201 line. You can see it's outside my root circle here, outside, a little closer. Oh, it's right on the root circle, or that one's close. That's right on. That's just a little bit outside, a little more outside, a little. And that's the maximum projection. And then we go back down again. And if you've seen rosettes, this should start to look familiar to you. And so then all you have to do, and again, depending on your CAD and what you use and how you do it, you then just, I call it just spline the rosette edge. This is just one spline curve that goes, it's from the endpoints of each of these tied together, ding, 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 all the way around. Done. And it's, yeah, it's symmetric. I should just be able to, flip it and mirror it down below, and I'm done. Well, that's not quite how it works. There's still some art involved here. If you notice, at the ends of this, if I just flip this design, I would have very sharp corners on these two parts of this rosette compared to these soft, bulgy corners that come out of the spline on the others. And so I can't just flip this. There's other ways I could mirror it and rotate it and duplicate it, but because this one's relatively simple and there aren't that many radial lines, it's easier to just spline around the entire thing. And this is the puffy polygon that we're all familiar with that produces the straight-edged polygon at a specific size. Does that make sense? I see some people asleep. I see some heads nodding. But bottom line is this is still an art form. It's not a, there's some science involved, but I'm here because De La Condamine taught me how to make rosettes. I'm going to pass my last prop around that Bonnie went and got for me. if I can get the microphone off. So just so you can see them, this is the Shamrock rosette, and this is the Shamrock cut. So this is just a great example of, doing exactly what I was describing, going from the 7-inch root diameter up to, or from the 2-inch design that I wanted to create up to the 7-inch root diameter. And it's just a real world example that I like because it shows people something as funky as the portrait, the cameo that De La Condamine used to try to illustrate his from the beginning. So the Shamrock is, like I said, it's a great example of a rosette that's asymmetric. It needs a lot of special attention. So if you notice, even though on that polygon I had all those evenly spaced lines, you can't get away with that here. So you'll see all these lines. I know there's places in here where the rubber and the cutter are going to have difficulty. So I have a huge density of radial lines in here that all translate to this outer periphery of the rosette you're seeing coming around. And so you just have to add some insight, some understanding of the process, both of what you can machine on the CNC to make the rosette itself and what the rubber and the cutter can get into and out of. Kind of like Eddie's discussion yesterday with trying to reproduce Gorst's triple finial, by changing the shape of the cutter and doing some other things. You know what cutter can get in there. I know what cutter most people are going to use on the machine that I'm targeting, and I know what kind of rubber they're going to use, so I can sort of accommodate that in my rosette. And in fact, for the MDF, I made a I modified the rosette. Instead of going down the path Eddie went down to modify the cutter with a concave side, I just modified the rosette to work with the cutters we know. And so you can change the problem depending on what you have control over. I can make rosettes, he could modify or have Chris modify a cutter, and you get the same result. And I like the Shamrock because it's a great illustration of sort of the extremes of where you can go with modern technology, and once you understand the problem of how rosettes need to be designed to then work on a machine to cut the pattern somebody's after. So, in closing, and look at that, I'm almost on time. This is grossly oversimplified. I'll go back to Bergeron's comment. If you can't make accurate rosettes, don't even try making rosettes because it will come back to bite you in the butt. But this is the concept. I want you to understand, and I don't know how many people in this room will actually go make rosettes, if any. So I balked when Brad originally asked me to do this talk. I said, I don't know that people in the room care about making rosettes, but I wanted to make it interesting enough so that you knew how they're made or how they're designed or how they work. But it's grossly oversimplified. That said, there are endless possibilities. I didn't talk about all the angular, the non-collinear examples that Ferraglio and De La Condamine talk about, but when you see that twisted wave, and John Sauer had some pieces in his talk yesterday, if anybody has cut significantly above center or below center, you'll see these crested hooked waves on your patterns. And that's one of the things that you can use De La Condamine's technique to actually explore all of those, but that's where the cutter and the rosette and the rubber are not collinear. So that I didn't talk about those cases, but there's tons and tons of possibilities. I barely touched on the near side, far side. We all know about the inversion, but there's a whole bunch of other things that are available if you have those in your sort of case to work with and your, the tools at your disposal. I didn't talk about cutter shape and tool compensation other than the mention of Eddie's experiments. You can change the cutter, you can change the rubber, you can change all these other things. And with CAD, you can put that rubber shape in, you can put the cutter in. So if I know somebody's using a 2-inch diameter fly cutter to make something, I have to make a different rosette to get into those places, the features on that rosette. But if you know it ahead of time, you can compensate for the rubber shape and the cutter. I didn't talk about the permutations and combinations, but again, the rubber shape itself, not just how sharp the point is. Like on the MDF, I tend to use a 3/8 roller bearing for my rubber just because I don't want to abuse the rosettes and on the complicated ones. So I know that's the diameter of the tip of the rubber. But if you've got a pointed rubber, or a T-shaped rubber, or any of the other shapes of rubbers, you can factor that into the design too. And then, like I said at the top, most of this is all dumbed down to be collinear so that the cutter, the rubber, and everything is on one line, not the angular example that Bergeron and De La Condamine dive into. And needless to say, the permutations and combinations are limitless. That said, I didn't want to interrupt Chris's talk last night, but in the guilloche and straight line world, there's a notion of rosettes that we don't typically have in the round machine world, where the rosettes themselves act in combinations. I call it ganged. And so there are patterns that, where the pattern itself can be made up of using multiple rosettes to each cut a portion of that pattern. You'll see them in the Van Dykes and some of the straight line work where there's sort of things that have one line going to two lines, going to three lines. It makes kind of pyramidal things. You'll see different shapes, and it's because they're using different pattern bars that in sequence, you use this pattern bar, then that one, then that one. We don't really have that concept of these complementary ganged round rosettes, but I think there's potential for that. I'm also very fascinated by organic asymmetric rosettes. There's a lot of things where, like Spirophylotaxis, the curves that you see like in a pine cone or a pineapple or some of the other vegetable families, you see these spirals in nature that are nested within each other and crossing over. I think there are interesting organic rosettes that can be combined to produce those kind of patterns too. So that's a particular personal fascination of mine. And then of course, I'm going down a path that's largely electronic now too. I like ornamental turning because I want the interaction with the machine, but that doesn't mean I'm going to dismiss the opportunity to have electronic rosettes that have never existed before. And so I think we live in a very interesting time where we have a lot of tools at our disposal, and you just have to selectively decide how much of the enjoyment that I derive is from manipulating the machine and how much is from the pattern that I can produce, and where do the two cross boundaries. I think it's just a wonderful time to live, to be standing on top of the shoulders of the giants I referred to, and I think there are no limits. Any questions, comments, confusions, things I left out?
Of like getting into the manufacturing side of it, I was wondering if you had experience with some of the different kinds of manufacturing and the pros and cons when it comes to rosettes, like wire EDM, laser, CNC, etc. What are the pros and cons you found among the different kinds of actual manufacturing when it comes to making some of these?
I've tried them all, and I'll just tell you, I'll jump to the answer, which is the reason I make the rosettes for the MDF the way I make them is because I tried them all. Steve, I don't know if he left the room, but when Steve and David started out, they had really coarse cut out Perspex plexiglass rosettes that looked like they were cut with a hacksaw. And Gorst looked at them and he said, that's never going to produce a good surface. The edge of the rosette, first and foremost, has to be perfectly smooth. Or anything that's on the rosette is going to get amplified in your workpiece. So you have to have a smooth cut. Laser, I never could get a laser, even though some people can kind of get laser cuts to work. The kerf is generally uncontrollable depending on the thickness of the material unless you have the laser in your hands and you can manage it. I've never been able to outsource laser work and get a good enough edge on a rosette at the tolerances I needed. EDM, I think you run into the same problem, and I did when I tried a few. I did laser in plastic, and I did laser in metal, and I did EDM in metal. EDM works, but it's going to cost you an arm and a leg to make a 7-inch rosette multiple at a time at the speed you need to go to get the surface finish. And you're typically going to use harder materials, so if you're going to post-finish it, sand and polish, whatever, there's a lot of work there. I use high-density polyethylene, which is the same as UHMW, but without the Teflon in it. I use 1/2 inch thick because if you've seen Jon Mo's machine, I knew from day one I was going to rub the edge of the rosette to do a bell crank pumping mechanism. So I needed a 1/2 inch thickness for the problem that somebody was talking about yesterday. When the rosette moves on the traversing mandrel, you can't have the rubber fall off the edge of the rosette. So that's why my rosettes are a 1/2 inch thick. But the HDPE is a very easily machinable material, and it's very forgiving, and you can cut it with router-like or CNC mill type speeds, single flute cutters, Harvey tool. Does everybody know about Harvey tool? Harvey tool sells expensive but weird long length end mills that'll let you do things in small diameters. Anyway, I've tried a lot of processes. I zeroed in on the HDPE as a very forgiving material to get the right surface finish.
But you're doing those CNC?
Yeah, they're all CNC. From CAD to CAM to CNC. There was a question out in the middle here. Oh, that was the same question. Okay. D?
Just a comment that I don't think you alluded to, I don't know if he explicit.
Excuse me, I can't hear what D is saying.
The sliding tool holder uses very simple cams. They don't have to be accurate. You know, you can rough them out on a jigsaw practically and generate very accurate Rose engine patterns because of the gear ratios. So for people who want to do Rose engine work simply, slide rests are something to look at.
Do you have personal experience? Because I do, and I can talk to that.
Go ahead.
I started with a Clare lathe, and the Clare rosettes are about, I think they were about 4 inches in diameter, and they had a surface finish on the edge that was pretty crappy. And I modified my lathe after years of other experiences to accommodate 7-inch rosettes. And what happens is the shrinking effect from the rosette, if you have a big rosette and you shrink down, you can get rid of a lot of the imperfections in the rosette through the reduction process. But the other advantage that you're alluding to is a huge one on those machines, which is you could do the gear multiplication. So you can take an F heart and have as many of them wrapped around as you want. And that's huge. But the size and the edge, you can't cut them out with a jigsaw and still have a good pattern on the wood, in my opinion. I've never been able to do that.
Well, I had an undulator, and I made cams for that were ugly.
Yeah, a slightly different machine, but yeah,
Right, but I mean, same principle.
yeah.
And the work that it generated was satisfactory to my eye.
Is it on the table? Is that it? Any other questions? Thank you very much.